Good afternoon, everybody. Welcome back to lecture number 11. Yes. Give me the paper. So the synchronous machine that we used in example 4, what was the problem? Last time the problem that we had excitation voltage need to be found. Power angle, we had the power factor, and we draw the phasor diagram. Part B, we increase the magnitude of EF by 20% by keeping the power the same. So if we keep the power the same, we equate the two power equations. Ultimately, we'll have EF1 sine delta 1 equal EF2 sine delta 2. This is the constant power operation. In part 3, what did we have? We said we're going to increase the field current. In part 2, if we increase the field current by 20%, EF will increase by also 20%, correct?
Yes.
Okay. Then, the last part, what happened is we started to increase the real power. If we increase the real power slowly, it was asking about stability limit. Stability limit delta equal
90.
delta equal to 90. Delta equal to 90. Then it asked about the usual things: power factor, real power, reactive power. How many equations we can use to calculate the reactive power? We have two equations. The first equation you can use is Q equal 3 V terminal. Everything is phase. IA sine of theta of V minus theta of IA, which you can, if you take VT as a reference, you can just call it minus theta of IA, the angle of this curve. The other equation is what? The one that has 3E VT over XS cosine square delta minus, no, not square.
Theta minus.
Was it theta or delta?
Theta minus. I think theta minus.
See, this equation I will give it to you in the exam because it's too long, okay? You don't have to memorize that. Remind me, okay? That's a promise. You keep the promise, okay?
Okay.
This is the equation.
Oh.
No, there is no theta. I did not
Okay.
formulate it. Cosine delta
The
minus
power
3 pt square over x of s. Okay? What else we have? So you have two methods to calculate. Now, in the fifth example, can you tell me about the ratings of the machine in 4? Is it a big machine or small machine?
Small.
Is it a generation facility machine or local building? Local. This is because it's 200 volt. It's a local generator. 5 kVA, that's not much. So, can we operate this machine as a motor? Yes. Why? Because those small machines, if we operate them as motors, what will happen? We still can maintain reasonable speed, low number of poles. Those machines in the generation facility, they do not have what we call the low inertia. Okay? So example number 5. Same machine, we operate it as motor. How did I know it operates as motor? It says here, operated as a synchronous motor. What is another key word?
Power factor.
Nope. Draws current. So in the exam, if you see it draws current, what does it mean?
Motor.
It's a motor. If it says supplies current, what is this? Generator. So these are other variations of whether to know if it's a motor or generator. One last thing, if you get stuck, if delta is positive, that's a generator. Delta is negative, that's a motor. Okay? In the phasor diagram, when you draw the phasor diagram of a motor, let's say this is VT, this is EF. Do you put here minus 30 or plus 30?
30 plus.
50.
So you just put it as a number and you know the direction is from this way to this way. So the direction is negative and the number here is 30. But in your calculations you put what?
Negative.
Minus 30, okay? Because we always take the reference from VT. So let's see what will happen. We have the same values, field excitation is adjusted such that the power factor is unity. What is this operation for a motor? Is it under-excited, over-excited, normal-excited?
Normal.
Normal-excited. So for both generator and motor, it is what? Normal-excited. The field he's telling me that the unity power factor when we draw 3 kilowatt. So that's another way of saying draw current. You can say draw current or draw power. Supplies current or supplies power. Okay? How many of you are taking senior design? So when you have your electrical specification, make sure it's what? It's power. Do not just say 5 volts. This is undermining the brain of your electrical engineering evaluator. Okay? So always use professional language. Do you want to know the story? قصة الكهربائي اللي جاني شقتي?
Yes, one.
Okay, so this is a very interesting story to tell you that electrical engineering is very important, and those electricians who work in the market, they do not know what they're doing. So I had a stove, electric stove, and every time every few months we smell a burn, and the plug is burned, okay? Plug is burned every time. The breaker tears off. So it turned out that if you have an electric oven, you can use these, but the plug itself has to be rated at more than 10 amps. The ones that we use for the laptops are rated at what? 5 amps max. So if you go to your electric oven, you see how much power is consumed. Do they tell you apparent power or real power? They tell you just real power. If they tell you the real power, can you size your
Socket.
no نفس التوصيلة نفس الراس حق الكهرباء? Yes. It turned out that the ones that we have, these with 3 triangles, the standard, it turned out these ones usually cannot withstand 13 amps. So you have to use ones that are like that. ما أدري شكلها غريب صح؟
Industrial.
It's not industrial, it's made only for electric ovens. Okay? So for your safety of your home, I'm just giving you advice. 2 things you need to do. 1, put smoke detector in the kitchen. Put smoke detector in the kitchen. You can connect it with Ring, whatever, or any security system. The other thing is always check the outlet of your electric oven. Sometimes even if it's burned, the current would still flow. So my advice to you, go to a certified electrician and check do this calculation. Check your electric oven, divide it by the voltage, divide by 220, or divide by 220 over square root of 3. Single phase, it is single phase. Divide just P over V, no threes. Get the maximum rated current, have a margin. Let's say the maximum current is 10, buy a one that's rated for 15. It's very expensive. Unfortunately, the market right now is only having the Chinese plug, made in China ones, but that's okay, it does the job. As long as it's rated, that's what matters. And if it looks weird shape, you have to change even your, do not use extensions, okay? Same story with the fire tool, okay? This is very practical information for the safety for you and your family. Many of our parents, they do not know this information. So you as electrical engineer, you should go and verify, okay?
دكتور الصف الجدول كيف اعرف الكرنت اللي تقدر تستحمله؟ هل
You have to check the data sheet, but most of them, they withstand 15 to 20 amps. The issue is the plug itself, راس التوصيلة, yes. Yes. في شيء عندكم, do you have an event?
والله
كنا في صار ناقص بروجكت.
Okay, توفيق. So I'm gonna mark you 8. If you don't repeat it, we'll erase it. So this is very important, okay? So it draws 3 kilowatt from the supply. Find the excitation voltage and the power angle. So here what did we do? We have cosine theta is 1. We know the real power, 3 kilowatt. We know VT. What do you need to calculate? IA. You calculate the magnitude of IA. So the magnitude of IA is 3,000 over 3 times 120. In your home, should you multiply by 3? In your home, it should be power over 220. Okay? Unless you have the old 120. So the current is 8.33 amp. We still need to know the angle. What is the angle of the current if we operate at unity power factor?
1.
If we operate at unity power factor, it means that VT is in phase with IA. So IA would have an angle of 0. That is why if we substitute IA, we put an angle of 0. And then you should get E of F to have this magnitude and number. I hope all of you can do this by a calculator by now. If you have issues with the calculator, let me know, okay? Then the magnitude is 137. The angle is minus 29. It's negative, so we are operating in a motoring mode. So this is just part A. If you want to do the phasor diagram, IA, and then multiply it by JXSIA, then extend it here, go to the tip. This is your EF. No, it's wrong. It was a generator. Because this is a motor. So J is like that, extended this way. So your EF should be something like that. Okay? تبغون خليكم تجيبون منقلة في الامتحان؟
لا شكرا.
ها؟
لا
تقريبا يا دكتور. تقريبا.
You want code?
كمان شكرا.
ها؟
خلينا مسائل وحلوين
But please make sure you understand how to do phasor diagram. Okay? خليك تجيب منقلة.
لا شكرا.
انت ما استخدمتها في الجامعة خليني الحين وخليك تستخدم.
لا استخدمتها ب 380.
380?
روت لوكس.
That's the only class that you use.
خلاص عاد هندسة كهربائية يعني دوائر.
We will use it. We'll discuss about it before the exam. If I forget, I forget. So part B, if the field excitation is held constant, what does it mean? It means the magnitude of EF is fixed. The shaft load is slowly increased. For some reason, if you're driving your EV, you're going up in the hill. If you're going up in the hill, you have to spend more power. Your shaft would experience more torque. the dynamics of your synchronous machine would increase the torque, thus it will pull more current even though the excitation is constant. For the permanent magnet synchronous motor, is the excitation constant or it varies?
Repeat, Doctor.
For the synchronous motor that has permanent magnet on the rotor,
Yes.
is the excitation constant or variable?
Constant.
It is constant. It's a fixed magnet, surface mount or interior mount, wherever we put the magnet. So this problem is applicable for EVs. You cannot change the excitation for synchronous motor. The only thing that you can change is the voltage, and you just control the voltage and the current and the frequency. Variable speed drive, power electronics, okay? So the case of constant field excitation is realistic in permanent magnet synchronous motor. So now we're experiencing a higher torque than usual. Find the maximum torque. Now, if we find the maximum torque, we know our delta now is what? 90 degrees, correct? No, not true. That the motor can deliver. Well, this is the equation. Oh, the field is constant. So the field is 137. But why he's using this equation, tan delta?
From the phasor diagram, Ij is down.
So if delta will change, right? For the same excitation, for the same V terminal, IA, is it the same? 8.33? Yes, IA is the same. The question is not asking about what's the maximum point of stability. The point is asking under these loading conditions, what is the new delta? So the new delta you calculated by the trigonometry. So you already have EF to be constant. VT is 120. This is my minus IAJXS, which is minus 29. What's the angle of EF right now? It was before. No, it is the same. Okay, no. That's the continuation. That's another way of solving this part. This is the yeah. معلش. هذه طريقة ثانية لحل السؤال. هذه طريقة part A. This is one method. Another method to solve it is using phasor diagram. إيش هذا؟ للعقول في راحة. So the motor torque will be developed at delta equal 90. So maximum torque is at delta 90. Do you want to operate your EV at 90?
No.
No, because your motor can lose synchronism. And then if it loses synchronism, what will happen?
Come unstable.
You cannot drive your car. So in electric golf cars, for some reason, when I remember this when I was working with one of the manufacturers for EVs, they by law in the United States, they are not allowed to increase. Golf car cannot drive 100 kilometers. But can the electric motor drive 100? Yes, so they cap it. They cap it. So one way to cap it is to use the inverter not to exceed a certain torque angle so that you don't have a certain torque.
طيب دقيقة الحين في الاي فيز يستخدم synchronous motors.
They use either induction motor or permanent magnet synchronous motor. Tesla uses both. Model Y uses two inductions, small ones. I think هذه
Cyber
شو اسمها؟
Cyber
I don't know about cyber trucks. But the blade they use a permanent magnet synchronous. I think they are also some of them they use another type of machine. It's called switched reluctance. Switched reluctance, the rotor is shaped as triangle. This is another type of machine. It's synchronous, but it doesn't use permanent magnet or it doesn't use DC excited. It uses another type of controlling the excitation. It's called switched reluctance. The reluctance would change. So what's the maximum torque? 3 times Vt If over 8, 6,000 watt. That's twice the usually the rated or the operated one. The operated here is 3 kilowatt. So do not allow your electric motor to drive, and then you divide maximum power by the synchronous speed. What's the equation? What is Ns? 120 F over, what's the number of pole?
Maybe 4.
Is it 4?
هي number of poles ولا number
4 pole, yeah.
ولا 4 pair؟
لا poles.
4
American way is poles. British way is pole.
اللي هو يعني بير ولا الفور هذه بير؟
No, we use poles. The American way is poles.
خلاص.
So 1, 2, 3, 4. The minimum is 2. Don't put 1. The British way, they use pole pairs, and then you would find the 2 factor in every equation. This is the UK textbooks. Use the American way. It's better. Just count number of poles.
Okay.
Because when you do FEA analysis, you just count how many poles. It's better than the pole pairs. So never put P equal to 1. P is either 2 or 4. It's an even number. So what is NS? Divide by 4. What's that? 120 over 16. Think what, 1800?
Yes.
Can you convert 1800? So omega is what? Omega is 2 pi over 60. Do you remember this formula in high school? No, not this. How to convert from radian?
Yes.
High school.
360.
Huh?
360.
No, not 360. In high school. الشدان على طا.
مش أتذكر لك high school.
لا دال على 180 تساوي دال على طا. هذا شيء زي كده. And then if you convert from radian to degree, you can convert from radian. This is how they define it. So this 2 pi and these numbers 60, it comes from the conversion from radian. So 60 because of what?
Frequency. Yes.
60 دقيقة 60 دقيقة.
This 60
60
is not
ثانية.
because of 60 seconds, not because 60 hertz. Because an hour has 60 seconds, something like that.
A minute has 60 seconds.
Basically, this 60 has nothing to do with the 60 hertz, okay? So even if you're at 50 hertz, this 60 would still be there, okay? That's my point. And هذه 60, it comes from a conversion from
minute to second.
radians to second to RP.
من RPM إلى radian per
RPM,
second.
yeah. It's a combination. This is physics, one of them. Okay, let's continue. So, any question about example number 5? So, unity power factor, I angle is 0. Maximum torque, delta is 90. And can we operate our motor in delta 90? No, that's the maximum torque. You should not even be close. I would say 80%. You can be 80% close to that. Never go to 90. So the torque, 32.8 newtons per meter, we should not actually have it. Maybe we should reach up to 28 and then stop. Because 32.8 we would lose synchronism.
So, Doctor, when choosing a motor, we should aim for higher torque than the one we will be driving on. Right?
Not really. Not really. It's a function of the gearbox that you're using. So the shaft is not directly connected to the tires. There is a gearbox, fiturus. These gearbox have, so you can, in your machine, it's high speed, low torque. In the other side of the gearbox, it's slower speed, higher torque. So you can even reduce your machine torque by 50% for the same gearbox, get another gearbox to get the same torque. يعني ماشين تعطيك 30 وماشين تعطيك 15. If your output by the EV is something that mechanical engineers are doing it. You can pick a smaller electric motor, but you should pick bigger gearbox. Or you can pick bigger electric motor, smaller gearbox. You should co-optimize the two designs, not only your motor. Get it?
Yes.
So your gearbox would have losses. The more expensive ones with complicated designs, warm drive, أشكال غريبة, whatever, you can pick even smaller motor. So why you always want to have low torque motor? To reduce electric current density. Ultimately, we will see when we study the dynamics of the machine, the torque is correlated with the electric current drawn from the battery. The higher the torque, the higher the electric current. So your problem with EVs is not the motor nor the gearbox. Your headache is the battery. That's what keeps EVs not favorable by many drivers.
Yes.
So I personally would not have a battery that would, I wouldn't have a motor drive system that would drain my battery. So your concern is your battery. So you should co-optimize the gearbox. I think Toyota or many other cars, what do? They combine the gearbox with the electric motor in a container. And then they call it electric hybrid motor drive or EV motor drive. And then they optimize, you can have two electric motors for one gearbox. You can have many designs, okay? So let's talk about the power factor control. Power factor control. So is this a motor or generator?
Motor.
So we're talking about power factor control. We use motors. It doesn't make sense I use a generator. So what is power factor control? In EE360 or EE463, we study what we call power factor correction. You remember that?
Yes.
Power factor correction. What was the solution? Everybody knows.
Capacitor bank.
Connect capacitor banks. But instead of connecting capacitors, I can connect electric motors and let them spin. Is that correct? Yes, we will see. So what will happen? For EF1, so this is the constant power operation. EF sine delta is constant power. For EF1, we have IA1. Where are you? This is IA1. So IA1 is lagging. So this is what? Underexcited motor. Okay? Underexcited means EF is smaller in magnitude than VT. And IA lags VT. If you increase, if you go to, this is lagging power factor. IA2 is what? Unity power factor. So what will happen if I have a unity power factor? My EF has increased in order to maintain constant VT. In the motor, am I maintaining my VT? Yes, from the infinite bus. So I can change the excitation EF of the motor by only changing the power factor by increasing EF2, I can make my power factor between IA and VT to be unity. If I increase the excitation, EF3, I will have IA3 to be leading. Thus, I improve my power factor, and this would act like a capacitor. I care about the relationship between VT and IA. Let me repeat one more time. For a lagging power factor, EF1 in magnitude is smaller. If I increase EF2, I'm going to have a unity power factor. If I increase to EF3, I'm going to have a leading power factor, which is overexcited. If I plot the armature current, IA, with respect to IF3, remember, IF3 corresponds 1-to-1 to EF, because we're operating at a nonlinear, at the linear region, not the nonlinear. So if I start from IF, I might have bigger EF. So this is the armature current. In magnitude, it's big. In magnitude, smaller. It goes back to big. correct? The only thing that changes is the angle. For this IF1 corresponds to EF1, I have a larger magnitude of IA, but my power factor is lagging, far from unity. Power factor is far from unity. If I have IF2, I'm going to have the smallest magnitude of IA, but I'm going to have a unity power factor. If I have EF3, I'm going to have the armature current go back higher in magnitude and the power factor would be leading. So the V curve is basically IA-EF or IF relationship. EF هي نفسها IF.
دكتور لما تقول باور فاكتور كوركشن قصدك للسيستم ولا للموتور؟
No, power factor of the terminal for the system, not the motor. يعني the power factor of VT
للبص.
IA for البص للبص terminal. فأنا لما أوصل موتور للتيرمينال I can change the power factor of this bus, this terminal, by changing the excitation.
بس مو الباور فاكتور للموتور usually 0.8.
I'm not using this motor as an actual motor. I'm just using it to control the relationship between IA and VT. The relationship between IA and VT by changing the field. I'm paying cost, I'm paying money, I'm increasing the excitation.
طب انا ليش اسوي كذا؟ ليش ما احط كاباستور وخلاص؟ ليش ممكن اني اختار؟
Because capacitors are expensive.
الموتور ارخص يعني.
Yeah, just loops.
Okay.
It's not only that, the capacitor, in order to change them, it's a capacitor bank. You increase them incrementally, you connect multiple banks.
صح.
However, for this, you can have linear operation. يعني you can have power factor 0.8654031 that accurately. The capacitor bank is incremental. Because you can control the field. Can we use permanent magnet synchronous motor? No. This is the regular field excited motor. So if you have motors, you can use them to control the power factors of the terminal. That's the right technical way. By changing what? EF. Sometimes I want a lagging, so I go and reduce my field. Sometimes I want unity power factor. If I'm connecting parallel load that is lagging, I would operate at EF3 leading to make the power factor of my bus unity. Yani for example, let's say that at VT I have my motor, synchronous motor, which is this one, and I have another load, say a house. If this house is consuming at 0.8 power factor, lagging, in order for me, I should operate my motor at whatever that corrects it, leading, instead of connecting a capacitor bank. Get it? Is it clear? If it's not clear, raise your hand. أنا ماني قاعد أستخدم الشافت torque, and I'm gonna show you now in a second.
هل اقدر استخدمه لو ابي استخدمه؟ لا اذا هذا الموتور اللي بستخدمه بس بيكون حتى احس الباور فاكتور.
If you use it, you would draw more current, and then you would, again, depending on how much load you put على الموتور, you should change IA, and then you would draw in the whole design. This is empty, so this motor operated at no load by design. By design, you do not call. This is what we call them condensers. This is what we call them synchronous condenser, if they are leading. We call them synchronous inductor if I want lagging power factor. Okay? So if the motor is operated at no load, all of my input power would go to either losses, friction, windage, spinning at the air, maybe small amount of copper losses. That's nothing. That's maybe, what, 2-3%? All of my other power would go into fixing the power factor. So if the motor losses are neglected, all of my input power would be almost negligible. I don't have a shaft. Shaft is spinning at the air. My load is the air. If my load is the air, my input power is too low. Can I say it's 0? Yes. So those motors are those synchronous condensers. They spin without any mechanical load connected to them. So this is one of the applications of synchronous motors, to correct the power factor. Depending, if I want them to operate as capacitors, I operate them as leading power factor. I connect capacitor in parallel of the house or the plant. Then the whole bus would be a unity power factor. If for some reason my house is operating at, let's say, at a leading power factor, I operate them as synchronous inductor. So here current is leading my VT by 90 degrees. Current is lagging my VT by what? 90 degrees. Question in the exam. What is the power factor of synchronous condenser? Apply the formula. Cosine of theta VT minus theta IA. صح ولا لا? What is theta of VT? 0. What is theta of IA?
No.
لا دي تكون
Plus 90. So minus 90. What is cosine 90?
0.
0. So that's a 0 leading power factor. Question in the exam. What is the power factor of a pure synchronous inductor? Cosine of? What is theta VT?
صفر.
صفر. What is theta of I?
minus 90.
Minus 90. So it will be plus 90. What will be? So this is what? Leading. This is 0. Lagging. What is the power factor of a pure capacitor? 0. Clear? So, because it's leading, pure leading, I use it to correct my terminal voltage of my system. Keep in mind, those condensers, they operate in parallel with any loads. Is there any benefit if I operate them alone? No. There has to be a reason why I'm running my synchronous condensers, to correct what? The power factor. So in the absence of a capacitor bank, what should I use?
motors.
Synchronous condenser. In the absence of a reactor, do you know what's a reactor? It's an inductor plant. What should I use?
Synchronous inductor.
Synchronous inductor. So those synchronous motors can be used as a replacement for synchronous, for capacitor banks or inductor banks. Clear? Any question? Okay. Keep in mind, is this EF overexcited or underexcited? EF is overexcited than the tip of the VT. This one, is EF underexcited or overexcited? Underexcited. How to change EF? Is it going to change by itself? No. You have to change the field excitation, the field current. Thus, if I ask a question in the exam, an engineer claimed that he designed a synchronous condenser using permanent magnet synchronous motor.
No.
Is this engineer
No.
honest engineer or a liar?
لا.
He's a liar. This engineer is a liar. Cannot have it. You cannot have permanent magnet synchronous condenser because you need to have field control. Now, if you go physically change the magnets, if for some reason, Osama, I don't know, make this an idea. You want to have a synchronous motor with changeable magnets. That's an application for synchronous condenser. Okay? Any other question? So let's look at this example, and I need to erase the board a little bit. So this question, we agree it has to be provided in the formula sheet, okay? But this one not. This one you have to memorize. In the exam, do you prefer to write your own formula sheet?
لا دي من عندك كده.
How about you all create a document together and you put the equations and then you create the class formula sheet?
وتحطها في الاختبار.
وأحطها في الاختبار. So it becomes a group work. I don't have time to do it. Can you do that?
شوف ان شاء الله كلها في جروب.
Okay, who is going to be represented for the formula sheet? One of you. Create Google Docs, share it with the class, start putting the equation.
بتتظبط بالجروب ما عليك
No, I need one representative. What's your name?
عادي
Ali.
علوان.
Ali Alwan. You're the formula sheet guy, okay? So you're responsible before the exam to give me a nice formula sheet, and I need to approve it. You can't put everything. Okay? So you need. I don't have time more to do formula sheet. So the class should have your own formula sheet, and it's be printed in the exam for all of you, not in the quizzes, for the major. Okay? So we have time. I think that's the best way. Now, another machine, 3-phase, 5 MVA. Is this big or small? From these numbers, can you guess?
big.
Can an electric vehicle have 11 kilovolts?
No.
No. Maximum is 1,000. 3-phase, 5 MVA, 11 kilovolts, 60 hertz, synchronous machine has a synchronous reactance of 10 ohms per phase. Ignore RA. It's connected to rated bus. And it's designed to operate as synchronous condenser. Okay. So it is a synchronous motor. Even though the ratings are huge, we are operating our what should be a generator in the motoring mode. Can I use it for EV?
No.
That's too much. So now you can understand that the power plant, we can change the generator in the power plant to work as
موتور.
condenser. To work as condenser. But what is the cost? Who's gonna pay the price? The exciter engineer, the engineer who's taking care of the exciter and controlling the field, gonna have to really focus, be careful not to ruin the grid. Because if the engineer who's operating the exciter, nowadays there is control mechanism to control it. Have to be careful not to ruin the power factor of your system. So neglect rotational losses. What does neglect rotational losses mean? Assume P input at no load to be 0. Assume the fact that the generator is spinning without mechanical load, that the P input is 0. How does this would impact our situation? It would say, we will see it now. But
neglect rotational losses يعني قصدك إنه ما في شيء على الموتور هذا والكندنسر.
yes, what I'm saying إنه you have this synchronous motor that's big. Assume that you ignore. It's a motor, صح?
أيوه.
Assume VT is fixed. Assume that neglect the losses, so it means P input power is 0. Why? Because my P output is 0 and my losses is what? 0. Why P output is 0? Because there is no mechanical load, no torque. In my synchronous motor, there is no load. Why P losses is 0? From this statement, neglect rotational losses. So this implies my input power is 0. So if my input power is 0, it means 0 equal 3 VT IA cosine theta. This implies IA times cosine theta is 0. Correct?
Yes.
But what is my cosine theta?
هو
Cosine theta is from the statement normal excitation. For part A, for normal excitation, find the stator current of the phasor diagram. So cosine theta is what? 1, because it's normal excited. So this implies IA is to be what?
0.
0. Does it make sense? Yes, it makes sense. If I'm not putting input power and I have a voltage in the terminal, the current has to be 0. If I'm ignoring the losses. The last part 2, if rotational losses is 80 kilowatt, we're not ignoring it. We will see how to solve it. But for now, IA is 0. So if you read this statement, the power for normal excitation power factor is 1, VT and IT are in phase. Since power IA is 0, from the equation, no power transfer, so delta is 0. So this implies that EF equal VT minus JXSIA, this is 0, صح? فEF equal VT. How to do a phasor diagram? This is VT. IA is 0. So what is IF? Equal. So IF equal. So what's my delta? Delta is 0. Is there any torque? No. No load. So torque angle is 0. It matches the sense that I don't have any torque. The moment I add a torque to my system, delta would start to appear, which is the phase difference between EF and VT. So is this part clear? So VT is EF, which is 11 over square root of 3. Why divided by square root of 3? Because this is a line to line. I assume it's Y connected. And when we do all of our equations, we use phase equations. We do not use line to line. Unless you use the power to be square root of 3 times V line, I line. But now I think it's better to use this. I prefer to use that. Okay? Time is up. Do you have any other questions? So next lecture we'll continue part B, okay? Any question about part A? Why IA is 0? Because this motor is connected at no load and we ignore the losses, so it's like spending no energy. It's like open circuit. Okay?
بس نستخدم الاي اف نزيد الاي اف بصير في باور.
Forget it, yeah, that's another system. The exciter is another system. The exciter, we عنده auxiliary power. If you remember the first lecture, the second lecture, we had the exciter that is connected to a low voltage AC. That's auxiliary. And now we're talking about the 11 kilovolt level system. Nothing is free. You're right. Any other question, please? If you want to leave, you can leave. I don't want to keep you from.
Fake quizzes until this.
The fake quiz until, no, I wouldn't consider this until here. Okay? Let's stop the recording.